Okay, so today we're going to continue what we did 2 days ago. I kind of cut the video short, even though it was 30 minutes long. I didn't finish with the standard deviation and probability distribution. And we're going to throw some extra stuff in there too to make all that stuff make sense. Okay, so we were talking about discrete and continuous random variables. I told you what sigma was, told you all the different stuff. Well, now we're going to take all that stuff and put it together. So I'm going to give you an example problem. We're going to talk about a probability distribution and standard deviation. Actually, let me define those before we do the problem. So standard deviation, okay, you will see this symbol when we talk about that. It is a little like O with a crazy hairdo. So it's an O with a crazy hairdo, okay? That, believe it or not, is a delta, lowercase delta in the Greek alphabet. Okay? Doesn't really matter. I'll probably ask you that on the test, but just because it's fun. Lowercase delta. What standard deviation is how far each p of xi is from the average. So, let me give you this big graph. Okay, so I give you a graph, and we've got something that looks like this. Okay, we've taken and we've graphed all our points across through there. Now, and I told you to graph the average. Well, the average would try and put this on a line. So, well, it would be continuous. This is my graph. Okay. So it would try and put a line, a straight line that would be as close to being up to all the points as it could be. Now, this line represents the average, okay, and my curvy line is where I have, these are my graphed probabilities, okay, P sub x of x. Okay. So that's where I've graphed all my little probabilities. So I graphed, like, remember we talked about 1/8 and 3/8 and all that stuff. So I've graphed all those and I've connected them and made a line. Okay. Now, standard deviation is how far this curvy line deviates from the actual line. So right here, what standard deviation does is it measures from there to there. Okay. And it'll tell you standard deviation. Deviation. So, if I always want my data to be as accurate as possible, as close to the average as I can get. Now, when we say average, I'm going to dig back in your brain for a couple of days. So this will probably be back till Monday or somewhere in there if I do the videos right. You should be thinking average is my what kind of probability? Remember, there's two types of probability. There's theoretical, and there's what? You remember the other one? And there is experimental. Theoretical and experimental. So my theoretical, remember, is what I think is going to happen. That's my theoretical. In other words, when I flip a coin, it's a 50-50 shot. That's my theoretical. My experimental is what I actually do with that. So my actual outcomes. So for this guy, my average would represent my, what I think should happen, what should happen, my theoretical. And my actual, so my actual probabilities would be my experimental. Good. Experimental. Okay, just kind of letting you make connections. Okay, so how far does my experimental probability differ from my theoretical, or my actual, what I actually got, differ from the average? Okay, so that's what standard deviation is. Now, there's a big ugly equation that I'm going to teach you, but before we get to the big ugly equation, we're going to talk about a probability distribution so that you can kind of put all this stuff together. So a probability distribution, I'm going to erase this. You need to go back and pause if you need to. Probability distribution is when we apply and graph data into a table using our xi, and information. So we're going to put all of the stuff we just figured out into a table and combine all of it, so that we can find our standard deviation, so we can find our average and all that stuff. So, yeah, let's talk about this. So if we are going to do, this is our example problem we'll talk about. We're going to look at a family with 3 kids. What are the chances? We're going to count the number of girls in those family with 3 kids. So we have someone gets really unlucky and they have 3 girls. So girl, girl, girl. Okay. Then you could have girl, boy, girl. You could have girl, girl, boy. You could have boy, girl, girl. Okay. You could have boy, boy, girl, boy, girl, boy, and girl, boy, boy. And then you could have boy, boy, boy. Boy, boy, boy. So it should be 3, boom, boom. Okay, so we have 8 possibilities, right? Now, my probability distribution deals with counting an outcome. So I'm going to make a table. How far can I go? Oh, I got plenty of room. Okay. So how many? We could have 4 different possibilities with the number of girls. We could have, let's do this before I do that. Remember when I told you that what x and px were? X was kind of my outcomes, okay? Like the number of outcomes. And px is the probability of those outcomes, okay? Then p of x of I is each of these individual ones. So we're going to talk about that for a second. So my possible outcomes, countable outcomes. How many girls could I have? I could have no girls. I could have 1 girl. I could have 2 girls. Or I could have all 3 girls. Okay? Those are my options. If I was counting the number of girls that a family will have. Now, all of these are now my xi's. They're my possible outcomes. I can have 0 girls, 1 girl, 2 girls, 3 girls. All of these will be my probabilities of those xi's. So p sub of x sub I. Beautiful. Now, what is my total? Okay? There are 1, 2, 3, 4, 5, 6, 7, 8. So all of these will be over 8. Something out of 8. Sorry, not these. I have not worked today. All of these will be out of 8. Because there are 8 possibilities. So how many of these 8 have no girls in them? Girl, this over here. 1. So this guy is 1/8. The possibility of having no girls is 1/8. Okay. What's the probability of having 1 girl? 1 girl and 1 girl and 1 girl. So I've got 1, 2, 3. So I have 3/8. It's the probability of having 2 girls. 2 girls, 2 girls, 2 girls. Also 3/8. And what's the probability of having all 3 girls? 1/8. Now, remember my little box I drew underneath the discrete random variable? I said that my probabilities have to add up to 1. So let's see how that works. 1/8 plus 3/8 is 4/8. Plus 3 more is 7/8. Plus 1 more is 8/8, which is 1. So we're good. Now, probabilities are not written as fractions. They're written as decimals. So what is 1/8 as a decimal? Well, 1 divided by 8, you put that in your calculator, you'll get 1.125. 3/8, 3 divided by 8, you get 0.375. If that's 3/8, then this is 3/8, 0.375. And 1/8 is 0.125. Okay, so that would be our probability distribution. This is the outcome. This is what we're trying to get. If I ask for a probability distribution, this is your answer. This is what you're trying to get. Okay, and honestly, you don't even have to have these on here. Okay, that's your goal, is this little chart. Okay, so I know there were some steps to that. So I'm going to write those out. Erase everything. Step 1, what did we find? Step 1, we found what we were looking for. So we found our X. So we figured out, oh, we're looking for the number of girls. Boom. Then we wrote all XIs. Okay, so we wrote out GGG, BBG, GBG, all those things. Okay. Then we wrote our found our probabilities, and then we put in the table. So that's how you find a probability distribution. Okay, those are your 4 little steps. Now we're going to talk about the average and standard deviation. So we're going to use the same problem and keep working with it. The average, you would think, what average means? You add everything up, divide by how many things you have. Not so much. I'm going to get rid of this too and just leave our chart. The average for this would be, if you were to find the total number of, if you surveyed 100 people who had 3 kids, what would the average be? What's the average number of girls they would have? That would be the problem you're looking for. Okay, so you surveyed 100 people. What's the average number of girls they should have? What's the average? Now, before we do the experimental, before we go ask those 100 groups, those 100 families, we're going to find the theoretical. So to find the theoretical, I'm going to give you a letter, another letter. So the average, okay, when we're talking about probability, you will see this symbol. It is a U with another foot. Okay, it is really a mu. That's the Greek letter, mu. And the equation for this, for mu, is sigma xi times pi, or times p, yeah. Okay. So the sum of my xi's times their probability. So my first xi I get to, remember this is x and these are my xi's. My first xi I get to is 0. Okay? What is the pi? What is the probability of that xi? It's 0.125. And since these are stuck together, it means multiply. So let's solve this. I'm trying to find my average. So I'm going to add up all of these. But my first one is xi, which is 0, times the pi. What's the probability of that 0? 0.125. Okay? And remember, it is a what? Sigma, which means sum, which means add. So I'm adding my next xi. So I did the first one. No, my next xi is 1. Times, what's its probability? 0.375. Keep going until we get all our xi's done. The next one is 2. 2 times, what's its probability? 0.375. Looks like a colon. Keep going. Plus, my next xi is 3 times its pi, 0.125. Plus, oh, we are out of xi's, so there is no plus. We're just going to get an equal now. So, I add these up. Put that in your calculator. 0 times 0.125 is 0. 1 times 0.375 is 0.75. Okay? 2 times 0.375. No, 1 times 0.375 is 3.375. 2 times 0.375 is 0.75. And 3 times 0.125 is 0.375. Okay. I just saw the math in my head for no reason. But put that in your calculator, add it all up, you will get this magic number. So that is my average. Okay, that's my average. And of that average, this would also be my, what is your average? Your average is your theoretical. Probability. That will be on your test. The average is theoretical probability. They're the same thing. Now, so what this means, this 1.5, if I went and asked 100 families with 3 kids, how many girls you have, and I added all those numbers up and divided by 100, because I have 100 families, I should get 1.5. Now, obviously you can't have a half a girl, but that should be our average. Now, to find the standard deviation, okay, for each of these, you would think, oh, well, you just take this and see how far this is from it. No, it is not that easy. I'm going to give you a big ugly equation, all right? And we're going to try and work through it. But what I'm going to teach you to do with standard deviation is to put it in your calculator. And I've been teaching for 16 minutes, which is a long one for me. So, believe it or not, I'm going to make this another video. So we're going to talk about standard deviation in our next one. I kind of told you what it was. We're going to talk about how to work with it and solve it and all that good stuff. So, this is my probability distribution. This is my average and how to find it.